materials, logistics, and eventually to hospital, healthcare, and financial engineering nowadays. And in past decade, especially led operations management has strongly support the realization of the digitalization. And I can summarize that for the modern operations management. This thinking means that we use the scientific method for the business management. And at the beginning, this discipline, this thinking are many applied in the field of manufacturing industry. But nowadays, they have already well developed to the discipline to measurement science. In the measurement science, which means that when we see a real world problem, they focus on the modeling method to see the process and use the data, put the data into the computer model to do the mathematical computing. Besides that, for nowadays, when we see the operations management, not only from the viewpoint of maximum benefit, but also from the viewpoint of social science, psychology, behavioral science, which means that when we optimize the benefit using the operations management thinking, conception, and methodology, we consider not only the benefit of the enterprise, but also the human being, the worker, employees. And so when I summarized, for especially for the day when we talk about operations management, they have the three scope. The first scope focus on the overall in the strategic view. They consider the business in the whole supply chain. Then this scope, supply chain configuration. In this scope, we will focus on the deployment of global production network and deployment of regional production and production with use the operations management methodology to make the production strategy decision. The second scope is more focused on the production line. On the other hand, it focuses on only a factory and try to optimize the production line. And the task, including the layout configurations, production process design, capacity design, design of storage buffers, and warehouse design. And overall, for the scope of the task there, the methodology. The methodology of the operations management. First one, for the operations management, we see the real world problem. The real world problem could be the overall, the macro view, the scope could be a whole supply chain. The scope could be a factory, a production line, or the scope could be only concentrated on the work cell. We see the real world. First one, we must observe. We must observe, go to the field to see the evidence. to see the real world. Then we try to set the boundary, understand the problem's boundary, where define the boundary. Only in the boundary, in a well-defined problem, we can use systematic methodology to solve the problem. So, in general, the methodology of operations management can be classified into the four stages. In the first stage, just I mentioned, is the problem definition. We go to the field to see the real world problem and set the problem boundary and define your reasonable or not. If we can put your solution into practice or not. So it's the fourth stage of the methodology of operations management. And exactly now we know the stage, but in detail, what's the methodology? Basically, for the operations management, we should make the decision. When we use only our experience, it's not enough. We need a systematic approach. So the most important stage is the model thinking, model thinking. We build model, find the solution from the model, and eventually we can test the feasibility of the solution by the model. The model thinking is the key point of the methodology for the operations management. Now we come to the issue, modeling. What kind of modeling method we can use for the operations management? In the World War One and World War Two, a methodology, several methodology has been well developed and summarize them operations management, in short, OR method, operations research method. And the operations research method can be classified into two categories. One category means deterministic approach. Again, when we use this approach, we first do the problem analysis. We see the problem and then we build the model. Then find the solution by the data and computing the result in the model. Find the solution in the model. For the determinist approach, in the field of operation research, the method can be listed as the following group. First one, named linear programming. Second one, nonlinear programming, integer programming, dynamic programming, sensitivity analysis, network planning, project management, PERT, CPM, game theory, or data envelope analysis. For this category of methodology, they describe the model, use the mathematical programming method, which means that all the data are considered to be a parameter, and every parameter and every variable can be calculated by an algebraic number. That, for example, here is a typical case of deterministic approach. In the operations management, we have limited resource. So we consider the available resource are limited. But we try to minimize, for example, minimize the CO2 emissions. And we combine them, use this mathematical programming method to find to define firstly the feasible solution, then use the mathematical approach to find the optimal solution. And it can be proved that for this approach, the the optimal solution must occur on the corner point. Or another method meant dynamic programming. Sometimes our planning for operations management have many stages. For one stage, two stage, and the following stage will depends on the result of the former stage. Then, for example, in this diagram, you see the decision can be identified to n stage, and each stage will have different outcome. And finally, we define our result, and eventually can from the result, we go backward to find our optimal decision. It's the dynamic programming. Another category for the method operation research is stochastic approach, which means that we do not use only a number available, an algebraic variable to define the evidence, but a random variable, The situation, the parameter, and decision variable, they are random variable, which means they following some stochastic distribution. For example, normal distribution, log normal distribution, Weber distribution, exponential distribution, and so on. So they have a range of variance. So we can find their average, their most possibility. They will locate on the result, but they still have some interval, the possibility. Following this approach, first one, again, the thinking, the methodology are the same. We define the problem analyze. Then we build the model. Then solve the model use the method, then estimate the decision interval. Be sure to know that the decision will not be exactly the value, but the interval. The method, I listed them as the following. For example, statistical analyze, regression analyze, time series, or decision tree analyze, stochastic process, waiting line theory, or in other words, the queuing theory, or the Markov chain, Markov decision process, reliability, or eventually computer simulation belong to this methodology category. The point is that the variable and the decision, they following some stochastic distribution, not exactly the value, only an interval. So again, especially one method now is quite popular, especially in nowadays, the so-called Industry 4.0 era, or the AI era, that the digital twin. Basically, the digital twin belong also to one of the methodology category. to operation research. For a problem, we have a real world problem. Again, we see the problem, build the model, but the model no matter only a mathematical model, but we translate the real world problem to the computer model. So you see, we use the computer model to describe, to, to be a digital twin of the real world. Then in this model, we can make the what if analyze, or eventually we can do the try and error decision. If I do so, what will be the result? If I take this action, what will be the result? A computer simulation. Okay, now you know the discipline and you know the methodology. Now I will introduce how can we use operations management, the concept and the method for the era of globalization, especially for nowadays. One point I mentioned here is for the global supply chain optimizations. Global supply chain optimization, just I mentioned that we have three viewpoints, three scope of operations management. In a more strategic view is the supply chain configuration. Here you see everywhere we face the issue of supply chain. For example, we eat chocolate every day or nearly every week. But the chocolate consumed in America, in India, in mainland China, in European, but basically the raw material, the cocoa pods, are not produced in the consumer country. How can we get that? You see this diagram, the cocoa pod are produced in Guatemala and Madagascar. Then they collect all of the chocolate pods, then transport them, for example, to the Hamburg seaport. In Hamburg seaport, they accumulate all of the raw chocolate pods. Then in Hamburg, from the seaport, they deliver them to the factory to produce the product. You see the history here. We have originally have the cocoa powder. Then, no matter it comes from the Guatemala or Madagascar, they are transported to the Hamburg harbor, then to the harbor, then by ship transportation to the Hamburg. Then to Hamburg, they will be delivered to the pre-processing factory. The pre-processing factory could be located in Brussels, could be located in Germany, could be located in France, could be located in Italy, and so on. And following, they do the production process to the finished product. Then the finished product will be delivered to the end customer. You see the whole story from the raw materials, the cocoa product, transportation by the sea transportation, and finally to the processing, production, to the distribution. Here, you can see the topology of the whole story is like a network from the raw materials to the end customer. In here, they have the following process and for the transport, for the raw material, for added value added processing, all story. No one in different countries.
Part of the Build Direct model. What this means for you is that we don't build anything until you order it. It allows us to deliver exactly the product that you want, what you need, for the lowest total cost of ownership. I hope you enjoyed this virtual tour, which highlights the best practices of our global fulfillment network. Thank you for choosing Dell.
Dell's global fulfillment network consists of facilities strategically located across the globe. This capability includes manufacturing centers for assembly of custom configured computing products, fulfillment centers to ensure rapid delivery of dissimilar items, and to provide additional technology rollout services. This is Dell's global fulfillment network. All of Dell's manufacturing centers use the same processes enabled by the same systems and are measured the same way. This ensures consistent award-winning quality across our global network and allows us to identify and implement best practices. Now, manufacturing centers operate. This is to your ship-to destination. At that point, the order is electronically transferred from Dell's order management system to the manufacturing scheduling system, where all orders, including yours, are sequenced into the production schedule every 2 hours. Every manufacturing center across the globe has a network of Dell servers that act as the brains of the facility. They receive orders from our order entry system. The servers keep track of work in process, and associates serialized parts are stored for download onto customers' machines as they move through the process. This portion of Custom Factory Integration, CFI, allows our customers to eliminate software installation upon receipt. Our build-to-order process generates requests for material required for customers' orders every 2 hours, during which the material is delivered to the factory and built to order. Since there are no warehouses, part inventories are low. Our process is unique in that we serialize at the front of our line. A unique identifier, the computer's name or service tag number, is created and printed onto a label in both human-readable and machine-readable barcode format. The service tag number is used by the inmates, which components to place into a wreath of the kitting line. All last step of the kitting process is ensures we deliver exactly what the customer expects. The box is then sealed and sent either straight to shipping or expects. The box is then sealed and sent either straight to shipping or to an order accumulation area. While all machines to complete a customer's order are started at the same time, they may not finish at the same time due to process variability. To ensure we ship a complete order to our customers, we stage finished machines until the final machine is done. The entire order is released to shipping for delivery to our customers through a merge center. Customer systems with additional items to complete their order. For example, monitors, printers, or computers manufactured at other Dell locations are combined into one shipment. Dell manages the complexity of this network so that our customers get exactly what they ordered when they need it.
Hi, I'm Kevin Rollins, and thank you for taking time to learn about our global fulfillment.
So, you see the case of the Dell's computer. It's the typical case of global supply chain. You see in the story, in the videos, that Dell, it has global market. To fulfill the demand of global market, they deploy many production factory. Totally, they have 6 production factory. And each production factory could have different functions. And thereby, when they receive the order from the headquarters, they can quick response and very quick flexible react to the market demand. You see, for example, here, for the computer production, the company has factory in Mexico and one factory in Vietnam, one factory in mainland China, in factory in Czech Republic. And here, each factory, they have different function. For example, just right now, you see they build a factory in mainland China, and then the when they produce the product, the semi-finished product will be delivered to the Czech. And finally, in the Czech Republic, they will assemble the final product and deliver the product to the distribution center, and thereby to fulfill the market demand in Europe. So how can we handle such an issue to do the global, to optimize their supply chain configurations? Here, first one, just I mentioned to you, the methodology of operations management, they have the following point. The first key point, see the problem. Second one, build the model. Third one, find the solution. The fourth one, take the solution in practice. So you see the first stage, we see the real world problem, there's computer, then we must build the model. Build the model means that we see the real world problem and use the topology to describe the model. And then we set our planning goal. The goal, for example, just right now, you see the there's computer. They would like to maximize the market demand fulfillment. On the other hand, you can also choose your planning goal could be maximum profit or the lead time or the minimum cost and so on. So based on the target, you see the structure, the network structure. Just right now, I mentioned that you see the supply chain is like a network from the raw materials, from the production, then to warehouse, then to the distribution center, finally to the marketing channel. We get the data, the raw data from the system. For example, just right now, you see the there's computer. They use the SAP system to get the data. The data put into the planning model and finally to find the decision variable to determine how much materials they should prepare, how many quantity they should produce, and how will be their inventory, and what will be their distribution plan, and finally, what will be the quantity available to deliver to the customer. How can we from the input? The input is the parameter. Output will be the decision variable. What will be get that? Put the data into the model. What will be the model? The model is like so. We have a network, supply network. And for each, just I mentioned to you, the methodology more focused on the mathematical programming, linear programming. So for each location, we have their flow. We define their mathematical formulation to describe, use the mathematical formulation to describe the behavior of the whole system and how to solve it, to find the solution. So since it's a network, when we solve the supply chain problem for each node in the supply chain, they flow into any node in the network must be equal to the flow output the node and plus the inventory. So we build the model like this one, use the mathematical programming approach for the flow into the node must be equal to the flow out to the flow, flow out from the flow, then plus the inventory, which means that all the materials flow in the supply chain must be conservation, follow the conservation law. So now we have built the model. How can we solve the model? Normally in operations management field, when we use the mathematical programming, one approach is that we use standard software to solve the model. The typical one is the IBM CPlex or another standard software named Lingo. These two standard software are typical solution package for the mathematical programming when you use the such kind of method to build the model. But in technical viewpoint, they still have their disadvantage. When the model is too big, the timing, the computing time will be very long, or eventually they cannot be solved. So in the practice, another way for the operations management field to find a solution is like we use the heuristic. Heuristic means that we do not find the real optimization, do not find exactly a solution, but we use some heuristic. We simplify the solution process and try to get the result in a reasonable time. For example, for the supply chain network, it's quite often that we use the backward planning, we decompose the supply network into the following block. For example, here, the supply chain is decomposed into 3 blocks, and each block will be solved individually by the heuristic method, not necessary to be optimized. And then our method can compare with the solution provide the CPlex to find out if the errors is acceptable or not. Or eventually, you can decompose by this approach from the warehouse to customer, production phase, and the production stage considered to 2 to 3 stage when the supply network is compressed. Or another approach, especially for nowadays, some people use the AI method named the AI algorithm. For example, use the genetic algorithm to shorten the solution time. In a reasonable time, we find acceptable solutions and compare the result. When the difference, the errors is acceptable, then we prefer in a practical application, we use the heuristic approach. Now we have the model, we have a solution method. How can we put them into practice in the global supply chain? Normally, so many companies they work together, so we need computer system, information system. Here I show you a real case. It's a system structure for such a way. Here you see the MPDSS, I mean the main planning, the master planning decision support system for the supply chain. We put the model to this MPDSS, and then they get the data from the SAP ERP system, put the data into the model, and finally they calculate the result, and they send the result to the customer, and finally the result send the feedback or eventually the demand forecast to the company. And this approach has already been realized and in practice. So we have our computer system and customer as their system. We use the model to calculation, our ERP system, and combine them with the solution with the customer's company. How is the performance? Is the performance good or not? First one, we check the computation result is reasonable or not. Okay, the error is acceptable. Then finally, we put them into practice. After about 1 year of observation, you can see that we have the improvement in the overall capacity optimization, the capacity utilization, and in the VMI inventory, which means that the overall supply chain inventory can be reduced. So such kind of approach you can apply to not only for the computers industry, for the, you see, for example, here, when you face such kind of industrial evidence, you have global many production site, production factory. How can you allocate your capacity? How can you design their flow? You can use such an approach. And this approach nowadays has already been widely applied in the electronic industry, for the food industry, for the car industry, or for the pharmaceutical industry. So, and just right now, I mentioned that also one method for computer simulation. Again, beside the method, I build a model, mathematical programming model. It's really very complex. In this AI era, the operations management normally has strongly connection with the application of computer. We can use computer simulation. We have such a global market. How can we deploy our production capacity? Here is alternative one. On the other hand, we have alternative two. Which one is better? We should make the decision. How can we do that? Of course, we can use the mathematical programming to find a suitable solution. But beside the mathematical programming approach, we can use the computer simulation. We translate the supply network into the computer program, the software package. The software package that I use, named the plant simulation issued by the Siemens Technomatics. And we build the network in the computer. Then we put the data into them. Then we use only several hours then to compare their result. First one, to make sure that the simulation result compared to the mathematical model, their difference is quite low, only 0.8%. So we can accept this approach. Then we put the data to them to compare the alternative one and alternative two. Finally, we can compare their result in terms of the total cost, in terms of their materials acquisition, and finally compare their outbound logistics in terms of their distribution. So such approach now, operations management has already widely applied for the global supply chain configuration, not only for the, just right now I mentioned the normal scenario. For example, we can use them to find the solution when, for example, for COVID-19, when any disruption in the global supply chain, what will be your analyze? Now we have to understand the operations management in the global era, globalization era. We can use them for the global supply chain management. The other scenario, we can use operation management for lean production, or eventually to realize a lean supply chain. The scope will be here. The scope focus on a factory. When the performance of a factory can be optimized, then they can contribute the overall performance of the global supply chain, especially for some industry. If they create their value by in a global base. For example, the automobiles industry, or I would like to show you my one real case, aerospace manufacturing industry. It's a partner company for GE. As you know, GE is a global company like the Dell computer. They produce the airplane, but to produce the airplane, the company GE must get the support from many suppliers. They produce the component for the airplane. How can we do that? They request them. The partner company must have a good performance. They must deliver their product on time, thereby that the GE can produce their airplane on time and in good quality. So here I show you they try to, on the request of the GE, they realize the lean production. They must have a 5S and facility layout and materials flow optimization, shop floor control, production planning, and then their production capacity must collaborate with the demand from the GE side. So they used 5-stage methodology. First one, 5S implementation. They must clean everywhere, must be arranged, which means that they use the scientific method to let the factory operation in regular. Then we must go to the layout, go to the field, go to the production field. How can we see the problem? You see, I said to you, first one, we see the problem, see the real world problem and define the problem, and then build the model, find the solution from the model, then put the solution into practice. Go to the field. You see here. We go to the field to see the factory. Work in 这个是专门做比较小的小零件，然后 Now we have seen the field. Then you must build your model, which means that we go to the shop floor, production shop floor, and see all of the production process, their flow in the factory. See the production flow in the factory. And then by the lean production, we analyze their production process. You see here, I develop a tools. So you see here, from each production stage, we analyze their production process. We analyze to know their processing time, their work in process, their working time, and so on, their production process. Then, from the production process, eventually, we use the software package to describe them, the whole production process, and get the data from the production field. Thereby, here, thereby you have this, you see this diagram, the flow diagram, the value stream diagram. Then, since we have the data for each step, what will be the work in process? How is the working time? Get the processing time. And finally, we see their control. How they control, they do the shop floor control and find the bottleneck. Where is the bottleneck? From the flow model, from the data, numerical data, to find where is the bottleneck. Then concentrate from the bottleneck to make improvement. Now, to see the result, you see here, before we do the improvement and gradually they go to the stable state regarding their production flow and considering their throughput and their cycle time, they get improvement. So the model, the little straw, when you see, just right now, I say one discipline of the operations management methodology is stochastic one, a queuing method, waiting line method. I use this method to optimize, to find the bottleneck and to optimize for the overall operations, for the shop floor, for the GE. Thereby, when the performance of the one factory can be optimized, thereby the final for the overall GE global supply chain can be optimized. And of course, between the supply chain, you cannot just send the data by email every day. You need a computer system. So the company have a war room, like the concept of a war room. Thereby, they share their daily performance with their headquarter company, GE. The GE can control and know their performance, know their bottleneck. Then thereby the partner in the company, they can work together to achieve the good performance. Now, you see the operations management in the global perspective, in the production, in the factory perspective. I summarize that operations management is a discipline originally from the first industrial revolution in England. They used the scientific method, engineering method to the production management. And a specialist approach in the World War I and World War II has well been improved, especially for the military logistics. After the World War I and World War II, this approach has been widely applied to the normal enterprise. And the methodology more strongly focused on the problem observation, real world problem understanding, especially you must go to the world to see the real world problem. And then you build a model. Then from the model, you try to find a solution. Eventually use the standard software or you find a heuristic method and you find the solution, finally put the solution into the practice. Now, the methodology has already, the operations management, I say, is already quite mature in the era of Industry 2.0. Now, we are stay in the era of Industry 3.0. The trend is that the operations management method, especially when you connect them to the globalization base, they will strongly combine with application of information technology. And besides that, this operation management discipline has been extended to the service industry, medical industry, and so on. Now, in the next generation, we say in the era of Industry 4.0, benefit and performance is not only goal. We apply the more advanced IT technology, named artificial intelligence or the digital technology. Besides that, we should also consider the CO2 emission when the company create the value. So we, in nowadays, especially in the new operations risk management, we consider the people, consider the environment, and the scope is more wide. And let me make a summary. In these hours, I make the introduction about operations management, introduce you the discipline, and show you the methodology. See the problem, build a model, find solution, put that in practice, and I use the Dell's computers Dell's computers example to let you see the operations management for global supply chain optimization. And I use the one partner company from the GE, one of my real case, to show you how can they apply to the lean production and eventually support the realization of the global lean supply chain for the GE. Now it's all for today for my presentation. Now I think we can go to discussion section. Thank you for your attention. Okay, thank you. Good morning. I think because the computer system problem, I cannot hear your problem clearly. Mm. Can you write your question in some short sentence to me because the computer issue? Oh, I see. And the policy in my government to set the new enterprise, I think, and it's really basically this question is out of scope for today's lecture. But I think I can give you some feedback for nowadays in the government in Taiwan, because especially for the next generation, you see, now we say it's a globalization, but another trend will be the deglobalization, which means that you see the tariff issue. So many companies they move now, especially nowadays, move from the mainland China to South Asian Pacific or move to India. Another generation will be the so-called local supply chain. So what will be the chance for the new enterprise? The thinking for my government is that for the next generation, the most competitive company, not the big company, like the Dell's computer, so big a company, but small and medium-sized company with innovation One keyword, small and medium enterprise. Second one, highly innovation. Highly innovation. Who can do that? Especially for the highly innovation, the young people. So you can see now in Taiwan and even in mainland China or in Germany, that they encourage the young people. They can build some new company, innovative company. They their their competitive advantage not come from the cost, but they can do the new thing, create new product in very short time. And then because the company is not so big, they do not need so many capital. Is the first one. More exactly speaking, what kind of industry? For example, you say for my home country in Taiwan. Now we focus on that for the robot industry. Robot industry. Because for the robot industry, we need is still the industry in developing, especially for the smart robot. Who can do the smart robot? Not the old engineer, but the young engineer. They have the innovation, they have the motivation, they have the creation and innovation capability. They 10 people, 20 people in one group to build such kind of the company. And they produce only one part. For example, the skin, the skin of the robot or the vision, the computer, the robot can see. And thereby, finally, a big robot company, they can assemble them together. So it's one trend for my home country. For your reference. I think it could be better when you can. It's the internet problem that I cannot hear your sound clearly. Sorry, I cannot understand your question so clear. Can you write down your question in short sentence? Because the internet problem, I cannot see your pronunciation correctly. So I cannot understand your. Please write down your question in two sentences. Sorry, I do not see your message. Oh, thank you. Okay, thank you. Thank you. Bye bye. You make a photo. Okay.